Hello! In this chapter 1.1, Prime Factorization from Course 1A, Singapore Math, we will do the independent practice. I'm sure you've watched the content video for this before we start the independent practice. If not, please have a look so that your concepts are clear and you can solve these questions easily with me. So let's get started. Circle all the prime numbers. You know what are prime numbers by now, right? Prime numbers have only two factors, the number itself and 1. Okay, so let's find all the prime numbers in this table. 1 is not a prime number. 2 we write as 2 times 1. That's it. We cannot write any other way. So we see that it has two factors, 2 and 1. So 2 is number itself and 1, right? So this is a prime number. Remember that 2 is the only even prime number. All the other prime numbers are odd numbers. So anytime you see an even number which is not 2, you can directly say that it is not a prime number. 3 we can write as 3 times 1 only, right? So this is a prime number. 4. How can you write 4? You can write 4 as 2 times 2, right? So 4 is not a prime number. So a number is a prime number only if it has two factors, and those two factors are the number itself and 1. And 4 is an even number, so of course it's not going to be a prime number. 5, we can write this as 5 times 1 only. There's no other way. So this is a prime number. 6, even number. So outright you can say that it is not a prime number. And also 6 can be written as 2 times 3, right? So this is not a prime number. 7, of course it's a prime number because we write 7 times 1. Then 8. 8 can be expressed as 2 times 4, right? So that's 8. So 8 is not a prime number. And 8 is an even number too. And as I said, only even number that's prime is 2. Okay? 9 can be written as 3 times 3 equals to 9. So it's not a prime number. 10, again, even number. We don't even have to think. But if you want, let's say it's 2 times 5, which is 10. So it's not a prime number. 11, yes, it's a prime number because you can say 11 times 1 is 11. That's it. You cannot do further anything. Okay? Not other factors. 11 and 1 are the only two factors of 11. 12, it's an even number. And we can write this as 2 times 6, right? So of course this is not a prime number. 13, we can write 13 times 1 is 13. That's it. So this is a prime number. 14 can be written as 2 times 7 is 14. So is this a prime number? No, it is not. 15, we can write this as 3 times 5. So is this a prime number? No. 16, even number. So of course it's not a prime number, and also it is 2 times 8. It can be 4 times 4. There are many ways, right? But we don't need all of them because we are not asked to list the factors. We're just asked whether it's a prime number or not. So 16 is not. 17, we write 17 times 1 equals to 17. That's it. So it is. 18, 2 times 9 is 18, right? Or you can say 3 times 6 is also 18. So this is not a prime number. 19, yes, it's a prime number because it's only 19 and 1. 20, of course not, because you can say 2 times 10, right? Or 4 times 5. 21 is what? 3 times 7. So it's not a prime number. Do you observe that you need to know your times tables very well to solve this kind of questions? So make sure you know your times tables at least until 15, and that will make your life much easy. And what's the way to learn? Write one times table, any one that you want to learn. Start singing with it, like sing it. 2 times 1 is 2, 2 times 2 is 4. So just make any tune that you like and keep singing the whole day, and that just stays in your head. Just like any song stays in your head, right? 22. How can we express 22? 2 times 11. So it's not a prime number. 23, we can write 23 times once. That's it. So yes, it's a prime number. 24, no, because you can say this is 3 times 8 or 4 times 6, right? So it's not. 25 is 5 times 5, right? So it is not. 26 is 13 times 2 is 26. So 26 is also not a prime number. 27, that's 9 times 3 is 27. So it's not a prime number. 28, even number, so you don't even have to do anything, but we can still say that this is 28 or 4 times 7, right? 29 is a prime number because 29 and 1 are only factors for that, okay? And 30, it's 3 times 10 or 5 times 6, right? So we have circled all the prime numbers. So from 1 to 30, how many prime numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 prime numbers. Rest all are not. So this is how you solve this question. Let's go to the next one. Express each number as a product of its prime factors. Now, in your book, you are given two methods, and I will be using both the methods here. Whichever method you feel like using, you can use. Okay. So, in the first method, we write 6 like this, and we make something like this, right? And we start with the lowest prime number. Which is the lowest? We start with 2. So, we'll go in the sequence. Okay. So 6 is an even number. So any even number is divisible by 2. That's a divisibility test for 2. When you see an even number, divide by 2. That's the first thing. Okay. So dividing by 2. 2 times 3 is 6. So you do this process until you reach here a prime number. And 3 is a prime number. So we don't need to do anything further. So that's method 1. In method 2, you write 6 like this and you say 2 times 3. And you keep doing this process until you reach a point where all the numbers are prime numbers. You will see and understand it better when we have bigger number. 6, this is the only step. So we can say that 6 is 2 times 3. This is a prime number, this is a prime number, right? So it's prime factors. Okay, let's do the next one. 15. How do? We write 15 here. And 15, is it an even number? No. So it's not divisible by 2. We'll go for the next prime number, which is 3. Now, how do we know whether this is divisible by 3 or not? 15 is a small number, you would know it. But if it was a huge number, how would you decide? For the divisibility test of 3, you have to add all the digits. So here we have 1 and 5. So that becomes 6. And in the 3's timetable, we have 6. So this number is divisible by 3. So we say 3 and that's times 5. 5 is a prime factor. We don't need to do anything further. And the second method is this, right? 3 times 5. So we say 15 equals to 3 times 5. And it's done. Let's go for the next one. How about you take a pause here while I'm solving? You also solve some questions by yourself and then we check. Sounds good? Let's go for it. 36. It's an even number. I'll start with 2. 2 times 18 is 36. If you want, you can check here. 36 divided by 2. 2 goes once in 3, right? So 1 is the remainder in 6. So 2 times 8 gives us 16. Right? So that's 18. 18 is an even number. So again, divide by 2. So 2 times 9. 9. We know it goes in the 3's times table, right? 9 is a multiple of 3. So we say 3 and that's 3 times 3 and it's done. So now here we say 36, method 2. 2 times 18, right? Now 2 is already a prime number. So we continue it as it is. Then 18 can be written as 2 times 9. Again, we write down this. This 2 also comes down. And now we divide this 3 times 3. So these are your prime factors. Do you see they are same? 2, 2, 3, 3. 2, 2, 3, 3. Okay, so no matter which method you use, the answer will always be same. So we can say that 36 is 2 times 2 times 3 times 3. You can check it. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. So that's a way to confirm that you have done it right. Next, 78. So it's an even number. I'll start with 2. So that is 2 times 3 is 6 and that's 7. So I give carry to the next number, right? 18. So 2 times 9 is 18. So let's see here, 39 times 2. That 9 times 2 is 18, 8, 1 carry. 2 times 3 is 6, 6 plus 1 is 7. Okay, so we have done the right work. Then this cannot be further divided by 2 because it's an odd number. Now 3 plus 9 is 12. 12 is basically 1 plus 2, that's 3. Okay, so 3. So of course it's divisible by 3. That was my divisibility test for 3. So 3, that's 1s and 3. 13 is a prime number, right? So let's do the other method. 78, that's 2 times 39, right? 2 comes down, then this we divide by 3, so that's 3 times 13. So it remains the same, right? So 78 equals to 2 times 3 times 13. Confirm your answer. 2 times 3 is 6. 6 times 13 is 78. So 13 times 6, 18. 1 here, that's 6 and that's 78. Okay? I may not do this process each time, but I suggest strongly that you follow this confirmation so that you know your answer is right. Next one, 81. Of course, not divisible by 2. 8 plus 1 is 9. So 9 is a multiple of 3. So we'll start with 3. 3 times 2 is 6. And that's 8. So we give 2 to the next one, right? So that becomes 21. 3 times 7 is 21. 2 and 7 is 9. Then of course divisible by 3. So 3 times 9. And we know this 3 and 3, right? So second method here. 3 times 27. Then you take this 3 down. That's 3 times 9. Take this 3 and this 3 down as they're already prime factors. And that's 3 and 3. We end here. So 81 is 3 times 3 times 3 times 3. Okay? Next, 144. It's an even number. So 2, 7, right? 2 times 7 is 14, first 2 digits, and then 2. That's 2. 2 times 3 is 6, that's 7. So we give 1 to the next number, right? So that's 12 now. So that is 6. Again 2, because it's still an even number, right? So that times 1, that's 2. So we give 1 to the next number, that becomes 16. So 2 times 8. Even number, 2 times 9. Now 9, we know it's 3 times 3. Okay? So let's do this here, the second method, 144. That's 2 times 72. Then you write this 2 as it is. This is 2 times 36, right? Now this method becomes easier because I've done this here. So that helps me, okay? And then we say 2, 2 again. This becomes 2 times 18. That's 2, that's 2, that's 2. And this becomes 2 times 9. That's 2, that's 2, that's 2, that's 2. And this is 3 and 3, right? 9 is 3 times 3. So 144 can be written as 2 times 2 times 2 times 2 times 3 times 3. Okay, prime factors. And it's done, right? Personally, if you ask me, I prefer this method. It goes much faster for me. And this helps me do this method. But if you are asked a particular method, you have to do that method. If not, do the one that you are more comfortable with. But I'm doing both here for your reference. Next is 245. We write it here. And it's not an even number. We'll not start with 2. Let's check whether it's divisible by 3. 2 plus 4 plus 5 is 11, which 1 plus 1 is 2. This is not divisible by 3. We go for the next prime number, which is 5. So 2, 3, 5. Okay, next one. And it ends with 5. So divisibility rule for 5 is the number should end with 5 or 0. If the number ends with 5 or with 0, it is divisible by 5. Because if you analyze the times table for 5, we have 5, 10, 15, 20, 25, 30, 35, 40, right? So all numbers ending with either 5 or 0. So that's the divisibility test for 5. So let's do it by 5. 24. So 5 goes 4 times. That's 20. 4 is for the next one. So that's 45. So 5 times 9 is 45. It's 49. You know what it is, right? It's 7. 7 times 7 gives us 49. See how important it is to know your times tables. So 245, we write this as 5 times 49. And this 5 comes down, and this is 7 times 7. So we say 245 is 5 times 7 times 7. And it's done. Okay? Ready for the next? 510. I know this is divisible by 5 because it ends with 0, and most of the students rush for that. I would suggest that go in the sequence. Like start with 2, the lowest prime number. So 2 times 2 is 4. So we give 1 to the next one. So it becomes 11. 2 times 5 is 10. And that's 11. So we give 1 to the next. So again 10. So that's 255. Right? Again, ends with 5. Don't rush to start dividing by 5. Do next test. That's 2 plus 5 plus 5, which is 12. So 1 plus 2 is 3. So I will divide with 3. So 25. 3 times 8 is 24. 1 carry to the next one, right? So that's 15. 3 goes 5 times. 8 plus 5 is 13. 1 plus 3 is 4. So this is not divisible by 3 anymore. So we go to the next prime number, which is 5. 5 times 1 is 5. We give 3 to the next one. So that's 35. 5 times 7 is 35. And 17 is a prime number. So 510, the second method. It's 2 times 255. Then this 2 comes down. So this becomes 3 times 85. 2 comes down, 3 comes down, and 85 is 5 times 17. So we say 510 is 2 times 3 times 5 times 17. Okay? Now this one, let me start with the second method first. So we say 250. We'll start with 2. So 2 goes how many times? In 2, it goes once, and 5, it goes twice, and 1 to the next one, right? So that's 5. 2 down, and 125. 1 plus 2 plus 5 is 8. So it's not divisible by 3. I'll go for 5 now because that for sure it is, right? So in 12, 5 will go 2 times. That's 10. 2 to the next number. That's 25. So that goes 5 times. There's 2 as it is, 5 as it is, and 25 we know it is 5 times 5. Okay? And the second method, 250, 2, that's 125. Now I'm using these numbers from here to write here. So that's 5 times 25. Like I have to look at this now. This 5 is done. So I have to look at this one now. So that's 5 times 5. Okay? So 250 can be written as 2 times 5 times 5 times 5. And then 1089. I'll do the second method first here as we did in the previous question. 1089. Not divisible by 2 for sure. It's an odd number. Now 1 plus 0 plus 8 plus 9 is how much? 18. So that's 1 plus 8, which is 9. So it is divisible by 3. So we will say 3. Now how many times? So we'll take first 2 digits here. 3 goes how many times? 3 times. And we will have a remainder 1, right? So we give that to 8. So that's 18 now. So 3 goes 6 times in 18. And then in 9, it goes 3 times. So we take this 3 down. Again, this one. Let's do this. 3 plus 6 plus 3. Actually, I don't even need to do that because each one of them individually is divisible by 3, right? So total will be definitely divisible by 3. So that is 12. And that can be written as 1 plus 2, which is 3. So let's say 3 times. Now this is easy one. 3 times 1 is 3. 3 times 2 is 6 and 3 times 1 is 3. Okay? So this 3 comes down, this 3 comes down, and 121. Know your times tables? Yes, 11 times 11 is 121. Okay? Let's do the other method, 1089. So I do 3, right? This line first. 3 times 3, 6, 3. Now this line, but only this part, okay? So that's 3 times 121. Now this 3 is already done, so we take this part. So that's 11 times 11. So 1089 is 3 times 3 times 11 times 11. And it's done. Good? Let's go to the next one. We have 2 more of this and then we move to other type of questions. So 4725. I'm going back to the first method now. I prefer this. Not divisible by 2 because it's an odd number. So let me do the divisibility test for 3 now. 4 plus 7 is 11. 11 plus 2 is 13. 13 plus 5 is 18. So this is 1 plus 8. That's 9. So it's divisible by 3. So we say 3. 3 goes once and 4. That's 3. 1 will be given to the next number. So that becomes 17. 3 times 5 is 15. So we give carry to the next one 2. So that becomes 22. 3 times 7 is 21. Carry to the next number 1. So that's again 5. Right? So this is how you can do the division right here instead of doing it separately. Again, 1 plus 5 plus 7 plus 5. 6, 13, 18. Right? So it is divisible by 3. 3 goes 5 times in 15. There is no remainder. 3 goes twice in 7 with a remainder of 1 because that's 6. And 3 times 5 is 15. Right? Next, let's check again. 5 plus 2 plus 5, which is 5 plus 2 is 7. 7 plus 5 is 12. So 1 plus 2 is 3. So yes, this is still divisible by 3. So we put 3 there. 3 goes once and 5. And we give 2 to the next one because 3 times 1 is only 3. Remainder will be 2. Now that's 22. 3 times 7 is 21. So that's 22. We give 1 remainder to the next one and it becomes 15. So that's again 5. Let's check. 1 plus 7 plus 5. That's 8. 8 plus 5 is 13. That's 1 plus 3 equals to 4. So of course this is not divisible by 3 anymore. And it ends with 5. So we'll go with 5 now. 5 times 3 is 15 and it's 17. So we give remainder 2 to the next one. So that's 25. 5 goes 5 times in 25. 5 times 7 and we end there because 7 is a prime number. So if you want to do this here, 4725. That's 3 times 1575, right? So this is what we wrote. So 3 remains as it is. And then it's basically, this is the combination that you will take next, right? So this becomes 3 times 525. 3 as it is, this 3 as it is. And now we take the next combination, which is this one. Okay? Because that 175 times 3 gives us 525. So we write this as 3 times 175, this 3 as it is, 3 as it is, 3 as it is. And now we take the next one. So this is the one that we have to take. So we say 5 times 35. 3 as it is, 3 as it is, 3 as it is, 5 as it is. And now we take the last combination here. That's 5 times 7. And we know 35 is 5 times 7. Okay? So we say 4, 7, 2, 5 equals to. How many 3's do we have? 3. So that's 3 times 3 times 3. 2 5's. So 5 times 5 times and only 1 7. And it's done. Good. Let's do the last one. 27000. That's 27,000, right? Start with 2. So that's once. That's thrice with 1 remainder, which is given to the next one. So that becomes 10. So that's 5. And 0, 0 will come as it is. Don't say, oh, 2 does not go in 0, so we just leave it. No, you have to get those 2 zeros down there. Again, with 2. 2 times 6 is 12. So this is 13. We give carry to the next one. That becomes 15. So 2 times 7 is 14. And it's 15. So we give 1 to the next one. Right? And that's 10. So 2 times 5. And this 0 will come down as it is. Again with 2. That's 3. Again 3 because that's 7. And we have to give carry to the next one, the remainder, right? That's 15. That times 7, 14. And we have extra 1 remainder. We give it to the next one. So that's 5. Now it's an odd number. So it's not going to work with 2 anymore. Now let's try to add this number mentally. 3 plus 3 is 6. 6 plus 7 is 13. 13 plus 5 is 18. 18 is 1 and 8, right? So 1 plus 8 is 9. 9. So yes, it's divisible by 3. Even if you don't do 18 as 1 plus 8, it's okay because 18 is a multiple of 3. So let's do 3. So of course 1 and 1, right? Then 2 times is 6. And then you have 1 as a remainder which is given to the next one. Then that's 15. So 3 goes 5 times. Let's do the addition mentally now. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 5 is 9. Multiple of 3. So we go with 3. Now we take these 2 digits together, 11. So 3 goes 3 times. That's 9. And it will have a remainder of 2. So this number becomes 22. So 3 times 7 is 21. So we give 1 to this. So that's 15. So 3 times 5 is 15. Let's do the calculations again. 3 plus 7 is 10. 10 plus 5 is 15. And 15 is a multiple of 3. So we again go with 3. So that's of course once. Then that's twice by giving remainder 1 to the next one. Right? Because 3 times 2 is 6, not 7. So we have a remainder which goes to the next digit. So that's 15. And 3 goes 5 times. 1 plus 2 is 3. 3 plus 5 is 8. Not a multiple of 3. So we go to the next prime number, which is 5. And of course, it ends with 5. So it has to be divisible by 5. So we write 5 here. And we take these 2 digits together, 12. So 5 goes twice, 10, right? So it's 12. We give the remainder 2 to the next one. So that's 25. So 5 goes 5 times. And 25, we of course know that's 5 times 5. And we end there because 5 is a prime number here. Let's do the second method here. 27000. Now here, I'm trying to do it a little differently. Watch what I am doing. So I'll say 2 times 13500. Right? This one is done. Now, I'm not going to write this 2 again. I have changed the color. So that's now this next one I'm going to use is this pair, right? So I will say 2 times 6750. Again, I go down and that's 2 times 3375, right? I've taken the next pair, this one. And then again, let's go down further. So that is 3 times 1125. We go to the next pair now. So that's 3 times this one now, right? The next one, 375. Again, we divide this further. So we are going to this one now, right? So that is 3 times 125. Further divide. We go to the next one, this one here now. So that's 5 times 25. And we come to the last one here now. So we say this is 5 times 5. What did you observe? What did I do? Each prime factor I wrote in a different color. For me to know that this is a prime factor, I don't need to do anything further. Unlike the previous process, let me show that. I was writing this number here each time, right? Which is how you are supposed to do as it's given in the book. But as you go into higher grades, you should be able to do this way also, where you write the prime factors as it is. Like you don't keep writing again to, you don't need to do that because 2 is a prime factor, you know that. So we can write this as 27000 equals to. Now how many 2's do I have? So it's 2 times 2 times 2. And how many 3's? 3 times, right? So 3 times 3 times 3. Of course, times will be here. And then how many 5's? 3 times again. 5 times 5 times 5. And it's done. Let's confirm here. Do we have the same way? You have 2, 3 times. Set of 3 again, 3 times. And this one, 3 times. So you have it. Okay. So this way it saves some time. But you can continue doing this. This is how it's given in your book. This was just to show you that how I can avoid writing that numbers again and again. Okay, so we have finished those questions and we are here. Describe the steps for writing 42 as a product of its prime factor. So it's basically what you have done so far. They're asking us to write steps for that, right? So if you have to write 42 as a product of its prime factors, what do we do? So first thing, we write 42 here and we divide by 2, right? So we will say the first step is to divide by the smallest prime number, right? Smallest prime number, which is 2 here because it's divisible. So we will say which is 2. So that's 21, right? Now 21 is not divisible by 2. So then we say, again, the same steps, divide by. Then we say next smallest prime number, okay? So 2 is not possible. So we go for 3. And 2 plus 1 is 3, right? So it's divisible by 3. And that's 7. And it's done. So you stop there, right? What are the steps? You divide by the smallest one. And then the quotient that you get here has to be further divided. If it's possible by the same prime number, you do that. If not, you go to the next smallest, that's 3, and you go on until you have all the prime numbers there, right? So that's how you do. And for 42 particularly, we started with 2, the smallest one, and it was divisible. And then we had 21. So basically here you have to check whether the number that you get, like this number here, is a prime number or not. If it is not, you go to the next smallest number. Okay, so this is how you solve this one. Let's go to the next one. 400 is this, okay? When written as a product of its prime factors, write 800 as a product of its prime factors. How are we supposed to do this? Why have they given us the prime factors of 400? Yes, you're right. You are right. What is 800? It's 400 times 2, right? Because 4 times 2 is 8. So 400 times 2 is 800. So what's the difference? It's this additional 2 that you have. So 800 can be written as, we will write all the prime factors of 400. So we write all these prime factors here. 2 times 2 times 2 times 2, right? 1, 2, 3, and 4. We have 5 and 5. So we say times 5 times 5. So that's 400, okay? And we have this 2 over here. So we say times 2. That's it. The prime factors for 400 were given and you wanted 800. There was extra 2 and that 2 is a prime number. So we just did times 2. So 800 is this. Okay, and if you want to rearrange, because these are 4 and that's 1, right? So we say 2 times 2 times 2 times 2 times 2. So we have 5 times now, right? And then 5 times 5, that's 800. Smart, yeah? Let's go to the next one. 320 is this. When written as a product of its prime factors, write 3200. So 3200 will be what? 320 times, we are using this because we know the factors for that, right? So we'll have to do times 10. So what's additional here? This times 10, which is 2 and 5, right? Those are the prime factors for that. So we say that 3200 equals to, first we'll write for 300 all this. So 1 2 3 4 5 6. 1 2 3 4 5 6. And then do we have 2 here? Yes. So we are going to write that 2 here now times 2. And then let's also write this 5. So times 5 because the next ones are 5 here and this 5 here. So times 5. And it's done, right? So let's count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1 and 2. Done. So that's how you do it. You don't need to start doing this 3200. Don't do that because answer is already given to you here. It's just that you had to multiply with 10 and write its factor. That's 2 and 5. Done. You want to try the next ones by yourself and come back and check? Please go ahead. 2700. Okay, we have the prime factors, right? 270. So 270 is what? 2700 divided by 10, right? So that's going to give us 270. So we write all the factors here for 2700. That's 2 times 2, 1, 2, 3. That's 3 times 3 times 3, and then 5 times 5 upon. How can you write 10? You can write 10 as 2 and 5, right? 2 times 5. Now, we take out the common factors. That's it. 2, 2 is out. 5, 5 is out. We are dividing with it, right? So what are we left with is the answer. So 270 equals to, that's only 1, 2 we have now. That's 3, 1, 2, and 3. And that's 1, 5. Done. Simple. You need to know what number to divide and what number to multiply. And if that's a prime number, it's simple. But if it's not a prime number, get prime factors of that number and then carry out the process. That's it. 4800, 4800 can be expressed in terms of its prime factors as this. Write 1200. Okay. 1200 in terms of 4800. How do we get that? If you want to get from 4800 to 1200, we need to divide it by 4, right? Because 12 times 4 is 48. Okay? So 12 times 4 is 48, right? That's what we are using. So number of zeros should not bother you because 2 zeros, they're balanced out. Okay? So now we will write the factors for 4800. So how many 2's we have? 1, 2, 3, 4, 5, 6. 2 times 2 times 2. 3, that's 4, that's 5, and that's 6, right? 1, 2, 3, 4, 5, 6. And then times 3, and then 5 is, we have 2 times. Divide by, how can we write 4? 4 can be written as 2 times 2, right? 4 is not a prime number, so we have to get the prime factors for 4, which is 2 times 2. The next process is to cancel the common terms. So 2, 2. Another 2, another 2. That's it. There's no more cancellation now. So we write the answer. So that becomes 1, 2, 3, 4. 1, 2, 3, 4. That's 3. And that's twice, right? So 5 and 5, and it's done. Simple, easy. Now write 120. How do we do 120 from 4800? That's a long, big number. Oh, it's confusing. No, 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 no. You have to use this one. So 120 will be what? 1200 upon what? We have to divide by 10, right? Then only the 0 and the 0 cancels, right? And that's how you get 120. So let me just rewrite this again here so that you're not confused. So it's 1200 divided by 10. And do we know the factors for 1200? Yes, it's here. So let's write it. That's 4, right? 1, 2, 3, 4. That's 3. And then you have 5 and 5. Upon 10 can be written as 2 and 5. Right? Cancel the common terms. 2, 2 out. 5, 5 out. What are we left with? 1, 2, 3. 1, 2, 3. Then you have 3 and you have 5. If you want, you can confirm your answer. Let's try checking our answer. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and 24 times 5 is 120. You check here, 24 times 5. That's 20, 0, 2 carry, that's 10 and 12, done. Okay, so that's just a way to check our answer. And it's done. So, how did you find this chapter? Wasn't it easy? It is easy, right? I hope you enjoyed solving this independence practice with me. You did, right? Great. See you soon in the content video for the next chapter, and we will keep solving all the independent practice from this book. So keep watching and enjoy maths. Goodbye.